So today we're looking at graphing linear functions. And we're going to take a look at how to do this for a variety of different formats that the equation could be presented to us. We can see in front of us there's kind of three primary options. One is general form, that's the one we'll look at first. The second is slope-intercept form, one that we've used plenty before, y equals mx plus b. And then finally point-slope form, which is basically the same thing as slope-intercept form, except the point could be anywhere along the line instead of in a specific place, the place where the graph crosses through the y-axis. But the first thing that we're going to look at is general form. Now, unlike the other two, we can't just look at the equation and obtain all the information we need for being able to draw the graph. We have to do a little bit of work. It's not hard work, but it's work. And so what we're going to do is we're going to determine the two intercepts, the x-intercept and the y-intercept. We want to find the two places that the graph crosses through the axes. Because if we know those two places, if we know 2 points, then we can graph our line. And so the x-intercept is the location where the graph crosses through the x-axis, meaning that the y-coordinate must be 0, because if we're on the x-axis, we draw a little coordinate plane for ourselves, here's the x, and here's the y. If we're on the x-axis, that means we haven't moved up or down. We've moved left and right, but we haven't moved up or down, so that means the value of y is 0. So what we're going to do then is we're going to plug in 0 in place of y in the equation. That will cause that piece of the equation to disappear, and then we can solve for x. We can figure out where the graph crosses through the x-axis. And then in a similar way, we're going to do the same thing to find the y-intercept. Except now, if we're on the y line, that means we haven't moved left or right. So that means x must equal 0. So we're going to plug in 0 for x into our equation. That'll leave us with just the y piece of the equation, so then we can solve for y and figure out what the y-intercept is. And so then if we know the two places where the graph crosses through these two axes, then we're going to be able to draw a line. The advantage of the other two forms that we'll look at later is that we don't have to do even that much work. We can just look at the equation and pull out all of the information that we need. But for general form, we've got a little bit of work. So in this example here, we see the equations written in that standard form. We've got the ax plus by, so 4x plus 2y equals 12. So we're going to find what these intercepts are. So the first thing we're going to do is we're going to find what the x-intercept is. So if you'll recall from the previous slide, that means we're going to replace y with 0. So we're going to go 4x plus 2 times 0. I'm replacing the y with the 0 equals 12. So this 2 times 0 just equals 0, so that goes away. So we just have 4x equals 12. And now we just divide both sides by 4. And so we get x equals 3. So the x-intercept is 3. So on my graph, I can go over to 1, 2, 3 and put a dot, and I know that my line is going to cross through the x-axis at that location. And then I've got to do the same thing for the y-intercept. So in this case, I'm going to plug in 0 in place of x. So I'm not moving left or right. I'm trying to figure out where we are along this y-line. So we replace x with 0. So we've got 4 times 0 plus 2y equals 12. So 4 times 0, again, is 0. So we're just left with 2y equals 12. And then if we divide both sides by 2, we get y equals 6. So that tells me that my graph is going to cross through the y-axis at 6. So I count up 1, 2, 3, 4, 5, 6, make a dot. And so now I know that my line is going to cross through those 2 points. So that's good enough for me to be able to sketch the graph.